All right. Without further ado, so first of all, thank you for all coming. Wait, I can't see everyone, so let's. I'd like to be able to see the fear in people's eyes as I ask questions. So maybe can we like push the middle a little bit back so that. Kind of like a bit of a circle situation going.
There we go. With the other bottle.
Okay, beautiful. Mic not working? Or is it working? No, it's not working.
Test, test.
Test. Wait, very good.
I really don't want to have to ask questions.
Chris and I can share if you want. Take this one.
No, I don't do sharing.
We weren't asking you to share.
Yeah.
Okay. Let's get started this way, and then we can keep going once the mic comes back online. So first of all, thank you so much for jumping on. I know Justin was a late addition to the panel as well. So part of the question that I want to do is to figure out what's the interface between the application layer of providing better guarantees to the users, and then the sort of sequencer validator layer of providing those guarantees to the user. So maybe a question is, does anyone want to sort of provide a perspective on how do we integrate both of those different components?
I mean, one insight is that if a wallet wants to provide pre-confirmations to a user, there's only one choice. Like, they can only send the user's transaction to one place. So in some sense, from the perspective of the wallet, there's one bit of entropy. Either I provide pre-confirmations or I don't. It's not like I choose who's doing the pre-confirmation. And so that should simplify the pre-confirmation story a little bit.
That one bit of information being what? Like the chain that's being executed on?
So either MetaMask supports pre-confirmation or it doesn't. It's a very binary thing. And if it does want to support it, then there's only one way to implement it, which is at any given slot, send the user transactions to the gateway or the sequencer that has monopoly power over that one slot.
What do you view, maybe to clarify this for me at least, since I haven't been so involved in the discourse, it would be helpful to understand what like our theory of the user is, like what a user sees or doesn't see one bit of information, right, as you put it. So what do you think the user wants that bit to represent?
Well, from the perspective of the user, it's either 42 millisecond latency or 12-second latency, if we're talking about base sequencing. So that's the one bit. And from the perspective of the wallet, it's either I give a green check mark after a block has confirmed the transaction, or I give a green check mark after I get a signed message on the shred that contains the user's transaction saying, I promise to include that shred in my future block.
And do you imagine a builder is involved here? Like you're passing the pre-conf all the way back through? I don't know anything about pre-conf, so I'm learning here.
So this is one of the beauties of pre-confirmations, is that it completely changes the block building dynamic. Today we have these powerful monolithic block builders, and by monolithic I mean that you have one entity building the whole block. And in particular, they can assert their economic dominance and enforce things like censorship over the whole block. On the other hand, with pre-confirmations, you have a direct connection between the user and the proposer. The builder has very little power, and you have this kind of top-of-block, shred by shred building that's happening, and basically the searchers are doing most of the heavy lifting on the transaction by transaction basis. So I agree that we have like these fatter proposers or fatter gateways, but we have much thinner builders.
I have a bunch of controversial takes on that. So maybe we can start spicing it up. And I do want to also make it sort of open to questions from the audience at the same time. So if we can have like a mic that's floating around, if anyone has something that they want to jump into the conversation, like don't wait to be called upon. I think maybe like someone at the hovering mic can just give access to the conversation. So one of the things I'm still trying to wrap my head around is, so we introduced this thing called PBS, right? And then we got these things called block builders, and then the block builders just keep doing more and more work. And we kind of like keep thinking that like we can add more work to these block builders. Vitalik, you published this post like a while back that talked about endgame, right? And how like the separation of the validators and the block builders was a desirable thing, and that like L2s are kind of approximating the same construction. If now we're making L2s based, are we basically just saying that now we're also bringing PBS to all the L2s, and now using the same, forgive the term, master nodes to be able to run the L2s as well?
I mean, it does depend a lot on the underlying architecture, right? Like if we go with one of these like multiple proposers on L1 ideas, then like all bets are off in a whole bunch of other directions, right? But I think in general, like the way that I think about layer 2s is that like basically, all layer 2s so far, like even the non-based ones, like they've been very PBS from day one. I mean, not even just PBS, like the closest that they've been to in terms of like the theory is like basically execution, like tickets or auctions or whatever you would call it, right? Except often, at least like the stated theory would be that you would like auction off the rights to be a sequencer for like even a day at a time or something like that, right? Or at least this was like the 2021 era thought in discussions with optimism people that I remember. So I think one of the questions is like, if that functionality exists, then like, if they become based, then that functionality gets aggregated in one actor. And one of the fundamental problems of has been basically like, how do we protect the decentralization of the L1 from like the horrors that like this entire space is bringing? Like my ideal world is DeFi doesn't exist, right? But,
well, yeah, exactly. That's the thing, right? Like one thing that's kind of beautiful about L2s is that you can kind of say like, okay, push all the like DeFi activity there,
right.
And then maybe we have a chance to keep the L1 decentralized.
Right, exactly.
But now if we're making L2 based, aren't we just bringing all of that back?
Yeah, I mean, it does basically put more dependencies on having some kind of quarantining that works at L1. And like, I think we need that anyway, right? Because activity happens on L1 anyway.
Wait, activity happens, well, right now it does, right?
Exactly, yeah. And like, I think
if you have longer block times, then maybe you push all that activity away from L1.
Well, that's like a maybe, right? It's like this is like one of those things where like, again, we don't want to like, stake the future of Ethereum on it, right? Like, activity is sticky.
Well, longer block times make people go to L2s. That was always my sort of troll way of how we fix MEV, is like we just keep increasing Ethereum block times until everyone goes to L2s, and then you've kind of like shifted the problem away.
Yeah. I mean, I agree that that's one of the quarantining strategies.
I mean,
right?
that's an interesting definition of the word fix you've used there. Wait, I want to interrogate you a little bit so I can understand, because it seems to me like you're trying to do what seem to me like two things here. One of those things is like give the users some additional guarantees so that they can, I don't know, move on with their life, like give away the car, like whatever it was that they were waiting on, confirmation of this like blockchain transaction to actually do. They need some confirmation of it, and then they can go actually do the real thing. Like in the hypothetical world that sadly we don't exist in, I would just be able to buy coffee in Brussels using Ethereum, and then I would key in my pre-confirmation for the guide, like give me my coffee so I can drink my coffee and go to my crypto conference panel, right? So that's like a thing we might want to give the user. And then the other thing you talked about is some kind of restructuring of the builder market. And as I understand that, it's something like there would be a chain of promises, and that chain of promises somehow goes all the way from a proposer or a future proposer to the user. And that chain could be like, I guess theoretically arbitrarily deep, although there are some efficiency considerations to keep in mind. And my question is sort of like, how related are these two goals to each other? And how much does it depend on what the user is actually doing? Like, can we really answer this question in a content-neutral way, if that makes sense?
Right, so there's these two types of pre-confirmations. There's execution pre-confirmations, which is the stronger type, where you know exactly how the transaction executes. So you know exactly how much gas you've paid, you know exactly your Uniswap execution price, and you even know the post-state route after executing the transaction, if that's information that you care about. And then there's the weaker type of pre-confirmation, which is just inclusion pre-confirmation. Now,
does that type make guarantees around ordering as well?
No guarantees around ordering, just guarantees on inclusion. So if you're doing a simple...
The only ordering guarantee is that that transaction gets in before any other conflicting transactions from the same account.
Got it.
Is the execution pre-confirmation even feasible? I mean, do you need information about the whole block?
Yes.
If you have a single block builder, it is.
I mean, right, as it exists.
But then the proposer's not giving you the pre-conf.
So this is where the top-up block comes in. Like, you have monopoly power over the next 12 seconds. You know the current state of the chain. And so if you want to give an execution pre-confirmation to the next user, the top-up block, you can guarantee that. And then you start building on top of that. And that's basically the Solana model where you have, ticks, and every tick you have a shred, and each shred is basically pre-confirmed. And the way that Solana does the pre-confirmation is with this thing called proof of history, where they have this fancy VDF thing where you've kind of committed with time. But you can also use collateral as your pre-confirmation commitment mechanism.
Oh, I have to ask another question. Okay. So I think a lot of what we've sort of been trying to see also is how do we orchestrate this ability for users to interact directly with the L1 versus directly with the L2 versus some other thing that may be able to interact with them. So I know, Vitalik, you've been very involved in the account abstraction space, which has the concept of paymasters and the ability to do this. And now I'm seeing more and more designs of teams that are trying to use the 4337 paymaster architecture to also be able to orchestrate things cross-chain. I'm wondering, maybe Arjun, you're working on Everclear. Do you want to share a bit of your perspective on how things are going to evolve for users who want to perform things in this cross-chain basis?
Yeah. I'm trying to contextualize it in a bit of the discussion that we just had, so I need to think a little bit about the implications of that. But at least from the way that we see it at the moment, we see this transition away from historically users having a direct relationship with the chain to instead users having relationships with solvers that are acting on their behalf. And this is particularly important in a cross-chain context where those solvers are also not just fulfilling transactions as relayers and providing data as potential cash swap style solvers, but also fronting capital. And that capital at stake is part of where the economic incentives behind credible accounts and things like that can come in. That's also where pre-confirmations ties in, where the solvers that are providing these guarantees need to be able to feel confident that their execution on the source chain is not going to get borked for whatever reason. And so being able to give those very sophisticated guarantees at the not at the application wallet layer, but instead at the chain layer makes a huge difference. And then there's sort of economies of scale that come with the amount of capital that you have to pay out as a solver for that service, or perhaps as a chain itself, depending on who's bearing that cost.
So, Sam, you guys implemented IBC.fun.
True.
Right? Which kind of leverages the fact that you have in the Cosmos ecosystem single slot finality, right, in many ways, to be able to achieve a lot of this. We had this dream at one point to bring single slot finality, but I learned today from Vitalik that that's no longer our dream. And so I'm wondering, how do you think about sort of the advantages of that in creating these multi-chain user interactions versus the difficulty of designing those in a system where you don't have single slot finality?
Oh yeah, I mean, this is why I'm lost on this panel, because it's just way easier.
My answer to this is these things are strictly additive, right? If you want to build an application that only operates off of finality, then you just wait the 12 seconds instead of 2, and you always have that ability.
Yeah, you just make the block times faster, and I mean there's still other issues for multi-domain, complex workflows, but it seems like you can kind of address those directly rather than oh, I have some kind of pseudo promise that this thing is going to happen here, but then I need to execute on the next domain. And once you start involving more than one domain, if you're going from L2 to L2 and you're just trying to get your tokens there, maybe that works. But if you're trying to use application functionality from this L2 and then do something over here, this is just going to be a absolute clusterfuck. I don't know how that's going to work.
But you're talking here like having full composability, so like applications calling back into each other, right?
Yeah. I mean, that's what we're doing in IBC.fun. Like, we'll like route you through 4 different chains to, swap on a DEX and then go over here and enter into a lending pool or something.
And that's not intermediated by any sort of solvers. That's going directly to the chains and to the validators.
There's a
on those
relayer,
chains.
an IBC relayer involved. We also support Hyperlane and a bunch of other protocols, but the constraints on those entities are they can delay transaction delivery, and they're also kind of replaceable in the system.
They're replaceable because they're just providing this like scheduling role of like this.
Yeah, there are external actors that observe the source chain. So there's a message to be passed, and anyone can relay. There are a couple different like flavors of this, depending on which bridge protocol you're using. But I mean, the end game could just be validators that are on one domain and also on the second domain. Just pick it up, and they already have the information. They just deliver it on the other side.
Got it. Okay. Chris.
Yes.
So tell me a bit about how all of this relates to Anoma. I mean, obviously Anoma has been pushing on the intense discussion and trying to provide better guarantees to the end users, regardless of the domain in which they're trying to execute, right? And it's kind of like this fully abstracted vision of if you're able to just focus on the fact that all of these different trust zones have different guarantees, you can kind of route user intents through all of them. That's how I conceptualize a lot of the work that sort of Anoma does. Do I have a correct sort of construction of this? And for you, how much do you care about the sequencing of each of the domains that are actually underneath it?
Mm-hmm. Yeah, I think that's a good characterization. I mean, the way I think about something like pre-confirmations is mostly that I think users really want different things. I think it's hard to reduce what users want. I mean, one bit of information for a specific, like representing a specific guarantee, yes, that makes sense. But I think different users want, like they actually want different things. Like some users want a guarantee that looks like an execution guarantee, and then the most efficient way to provide that to them in a decentralized way, I think is like usually going to be to have multiple consensi. So rather than those users waiting on or trying to get a like secondary guarantee from a proposer and some main chain consensus, the solver or the market maker, whoever holds the capital, if they hold enough capital to match the user intents directly, they just like run their consensus, which could be consensus of one party. And maybe the user looks and sees, oh, there's some background process checking that the solver has like way more staked on some main chain than the capital they're fronting to the user. So the user will be able to, the user has some reason to trust that the solver will actually like not lie about the order of the transactions when they ultimately settle it later on. But I think there's a difference between the user that like most users who want really fast execution guarantees, really fast swaps, are not swapping like hundreds of millions of dollars. They're just not. And they can get by with lower security guarantees. And then we don't need to build, for that specific purpose, I would argue that we don't need to build this chain of promises auction system, although I think it's interesting from a theoretical perspective. But I'm not sure that that's what users actually want. The other thing you mentioned, inclusion guarantees, as far as I understand, an inclusion guarantee is basically just a guarantee that the data will be published, like you have no idea of how it will be ordered or what the results of executing the transaction will be. And that seems to me like it's useful, but a very different thing.
I guess the nice thing about the model, like the solver model, is that ultimately, even if it is something that is intrinsically valuable for users, because you find that there are users that want to swap hundreds of millions of dollars in seconds or milliseconds. Like the point of the solver model is that you are kind of like offloading this to them. So if there is ultimately a market for solvers to go and purchase, stronger execution guarantees, they will do that.
Vitalik, you look like you disagreed with something.
Yeah, no. I mean, I think one kind of assumption that I think often is like implicit in a lot of these circles that I want to push back against is the idea that like the average user even is a user of like these DeFi protocols. Like, okay, so like, what are the last 10 things that I used Ethereum for? Like, one, sending sending people USDC. Two, depositing into a privacy protocol, withdrawing from a privacy protocol, updating my ENS domain, right? Like paying for coffees, like all of these things, I don't give a crap of like like what the post-state route will be, right?
Did you need a pre-confirmation?
I mean, I would love one actually.
You would love a pre-confirmation.
Yeah, and the reason why I would love I would love to have that payment be confirmed in 1 second instead of 12. But in that particular case, the inclusion guarantee is like exactly what you need, right?
Because, right, because they're non-conflicting.
Yeah,
right, exactly. They're non-conflicting, and so I think like we should take care to like basically avoid over-optimizing for the crazy power users and like forget that like this kind of activity exists. Right?
Why don't we just censor all the DeFi, like censorship?
That's what Stephane wants.
Keep the DeFi away from the L1,
Make the block times 20 minutes.
I think there's a case for longer block times here.
I do too, actually.
Yeah.
I mean, if the inclusion pre-confirmations provide 80% of the value, that's actually like fantastic news because they're so much easier to build, and not only that, but we can provide them very, very easily on layer 1 as well, not just at layer 2.
It seems like we almost have to pick a user and like optimize for that user. It's hard to be content neutral.
Yeah, I mean, initially, my initial intuition was the same as Vitalik, that most users just want to do simple transfers and then it's fine. And then I talked to various L2s and to like people who love DEXs, like the Paradigm people, and like, no, we need to know immediately what the price I'm getting on a Uniswap trade is. But the market will tell where the demand is.
Paradigm can run a solver. They have like enough money, right?
Right. But like the one thing that I think pre-confs like does not, like one type of user that I want to try and remove from the design space is like the entity like trading $100 million. And the reason is that you would need the pre-confer to have like enormous amounts of collateral to provide insurance for that. And so I am much more interested in the fat tail, the short tail, I guess. Yeah.
Do you guys think that supporting that kind of experience would actually unlock new ways of using Ethereum that are not currently possible, that are actually inherently valuable outside of paying for coffee, ENS, etc.?
I mean, like video games on chain would be cool.
Right.
But I think other examples, I mean, just like actual like replacements for more categories of like Web 2 applications on chain, right? I mean, like even if you think of like stuff like like the various social media applications, like I mean, I know for a lot of them like they use CRDTs, and that's probably even better for them for a lot of cases. But there's like still individual actions that would be nice if you could get them done in 1 second instead of 12.
Easier to insure too.
So I always thought that was kind of like one of the nice things about rollups is that you kind of have this like bring your own consensus. Like you can then specialize each rollup on specific applications that do a specific job for the types of users that care about that job. And then it kind of shifts the problem to, okay, how do we make it easier for users to go into that rollup and like out of that rollup and allow that rollup to then specialize into providing those guarantees. And a lot of the chain abstraction work I think is around this, but pre-confirmations also help enable this by helping the users or helping the solvers or helping the users bridge, get access to better guarantees on each of the chains that they operate against. I think there's a question that's involved in all of this, which is how do these pre-confirmations get enforced? And like, is this like an in-protocol thing? Is this an out-of-protocol thing? Is this a generalized way of enforcing? I'm sort of wondering, like, whether it's a based situation or not. How do we sort of expect validator or sequencer commitments to be enforced?
So ultimately, pre-confirmations are off-chain bilateral agreements between a user and a sequencer. And like, if they want to keep that private, like, the world doesn't have to know that this transaction was even pre-confirmed. Now, like, the same kind of very natural way to do it is just to have a smart contract where the sequencer, the pre-confer, puts forward collateral, and then there's slashing conditions that are agreed upon with the user. For example, if I don't include the transaction that I promised to include, then I get slashed. And not only can we have slashing, but there could also be like some sort of insurance compensation mechanism where the user gets compensated. Now, the whole point of pre-confirmations, if we kind of zoom out, is to make base sequencing work. The whole point of base sequencing is to make shared sequencing work, and the whole point of shared sequencing is to fix Ethereum fragmentation. And so, in order to fulfill this kind of shared sequencing and fixing fragmentation, we need the pre-confirmations to be maximally credibly neutral. And the reason is that we kind of want everyone to opt in to the same pre-confirmation mechanism, otherwise we're not really fixing fragmentation. And so one of the design, strong design criteria is that the mechanism by which you register and opt in as a pre-confer shouldn't depend, for example, on any like restaking like platform, on Eigenlayer or whatever it is. So you come in with raw ETH. It's a 100-line of code smart contract. It's super simple. There's no external dependencies. It's all open source. It's all maintained. There's no governance. All of these things, so that we can all agree that yes, this is a credibly neutral kind of registration mechanism to opt in as a sequencer, and then all the rollups have the same source of truth as to like who is the next sequencer for the next lot.
It seems extremely challenging to price the insurance there.
I'm actually a little bit lost on a prior point. Why do you need everyone to agree on one pre-confirmation mechanism to fix fragmentation?
Because the only entity that can give the pre-confirmation is the next sequencer. And in order to have shared sequencing, we all need to agree on who the next sequencer is. So if you have like 10 different rollups that want shared sequencing, then you all need to agree that on the next lot, it's this guy, this pub key that is the sequencer.
But so are you talking about like what kind of fragmentation are you talking about? Like state, application, rollup?
So fragmentation of composability and state across the rollup. So one typical.
I see. But if you make the pre-confirmation guarantee the actual like social point of consensus, doesn't it just become consensus?
The point of agreement is on who the next sequencer is. And there is no consensus in the sense that you're just reusing the existing L1 consensus. So you have a subset of the L1 proposers that opt in, that register as pre-confers, and like they are the sequencers. I
think there's this like fascinating symmetry with like Bitcoin ecosystem where at some point it just like stopped doing hard forks and only started doing soft forks, and it kind of sounds like that's what we're doing with Ethereum. Like now we're just like creating coordination mechanisms for validators to be able to offer like additional commitments and like over consensus. Is that like a valid way to characterize it?
Ethereum actually.
That's why I'm advocating nuking all this stuff and replacing it with native L1 functionalities.
Replacing it with what?
Native L1 function.
Wait, nuking what stuff? Like pre-confirmations?
Okay, well, it depends. For example, over the last couple of hours, this whole idea of like having n parallel proposers per slot has kind of grown on me, right? So you have like, n parallel actors, and then you just order by fee at the end. Like, the more I think about it, it's like, if we do that, then like, fine, we eat the complexity of having, like multi-proposers, which is significant complexity, and we should admit it. But on the other hand, like, single secret leader election becomes trivial because you lose the single, and so you can use per proposer randomness, and then inclusionless, you can kick that out, and then like the whole APS thing, you can basically nuke that, right?
Right.
Yeah.
So the only thing we really need, in my opinion, to fix fragmentation is we need a very strong shelling point on the shared sequencer, and it needs to be credibly neutral. It needs to be extremely secure. And in some sense, pre-confirmations are just a means to an end to try and make the base sequencer good enough. But if we could make it good enough with shorter slot times or with multi-proposers, that's great. Then we don't need the pre-confirmations necessarily. The problem with shorter slot times and multi-proposers is the EIP process and hard forks. It's just way too slow. It's going to take years potentially. And this is something that we can do without having to go to all-core devs, because I hate going on all-core devs, and I can just build.
This is some authoritarian shit right here.
We have, a test net. Actually, right now at EVCC, we had a dev net at Berlin, and we'll have mainnet by the end of this year. And this is the luxury that we have of not having to need a hard fork.
Okay, so I'm trying to, you, Justin, are a user of Ethereum, and it sounds like what you want, I assume you're a user of Ethereum.
Yes.
It sounds like what you want is atomic composability across rollups, something like that. This is what you mean fundamentally by defragmentation.
Yes.
Right, okay. Now I see why you go for this route. But I still think that it's not going to replace rollups, because there's, ordering is the most expensive thing, like in a physically distributed universe. It's always going to have fundamental costs, and ordering things that don't depend on each other in one place is always going to be more expensive than ordering them in multiple places. So it seems to me like if you want to create the Schelling point for ordering and atomic composability, what it makes sense to order there is really this social question. Like, you almost have to decide which transactions you want to accept because you want to order things that are codependent on each other, right? So wouldn't rollups that are doing different things with state that doesn't need to touch each other just want to use different, they wouldn't want to use the same proposer necessarily. It's more expensive.
So the goal is not to get rid of rollups. The goal is to empower rollups. And one of the things is how much composability does any given rollup need or want. And if it has this desire for composability because of network effects, then it's better that we all kind of agree on one shared sequencer. But you're right that some rollups will just be totally isolated.
I don't even think this is a decision the rollups can make. This is a scheduling problem, right? Users ultimately are sending intents and transactions into the system, and those intents and transactions touch particular parts of state. And the most efficient way to order those intents or transactions depends on the content. You can't fix the topology, right?
Right. So I think what you're alluding to is the fact that synchronous composability is a scarce resource. You can only have so many locks per unit of state, per unit of time. And the good news is that we know how to deal with scarce resources on Ethereum. We have block space as a scarce resource. We have markets. And what I think we should move towards is this idea that by default, a user transaction is a simple thing, like a transfer, and it doesn't need synchronous composability. But when there is a value add to synchronous composability, you have the option to pay for the luxury of buying this lock, basically. And this would be brokered through the builders or the gateways or whatever you want to call them.
What kind of, and I mean, this is just following on with this line of thinking, under this scheme, what kind of execution latency guarantees are you giving to a user transacting on across L2s?
So it's one ping time plus one tick time. So let me explain. So the tick time is kind of the amount of time it takes for the gateway or the sequencer to issue one shred. In the context of Solana, it's 400 milliseconds divided by 32, which is 12.5 milliseconds. And then there's, in addition to that, the time it takes for the user to connect to the gateway or the sequencer, which is one ping time. So if you're very close to the sequencer, let's say you're only 30 milliseconds, and the tick time is 12 milliseconds, then you get a 42 millisecond pre-confirmation.
So
are L2s asking for
Did you reverse engineer those numbers to get the 42
yes.
milliseconds?
Well, not the 12.5.
Okay, yeah. Okay, so you subtracted.
I just subtracted, yes.
The two further questions are, well, one further question is, in this scheme, do you expect a sequencer to be holding locks across all rollups that are a part of the scheme? So is the expectation here that a rollup is only sequencing, or sorry, a sequencer, a base sequencer that's doing this is only sequencing some subset of the total set of rollups?
So what will happen is that you have the rollups opting into a shared sequencer. This one sequencer for this one slot has monopoly power to build blocks for all the rollups. Through PBS or through this delegation to a gateway, the gateway would be doing the job of managing all the locks. And that job is basically to build the most valuable block, just like PBS. and they can rely on searchers and builders to do that. And if there's some sort of long tail roll-up that has very small amount of transaction fees, well, you're basically going to have some sort of long tail searcher that will provide a bundle with those fees.
So I agree that this is a coordination problem, but I don't think it's necessarily like a market coordination problem. I think it's like a content coordination problem. Like if you want, the synchronous composability is most valuable for transactions and intents which touch the same state. So for example, if Ethereum if people want, I don't know, a lot of DeFi action happening on Ethereum, they should have the Ethereum main chain own their DeFi state, and then atomic synchronous composability is valuable for transactions which touch that state. If Ethereum doesn't want DeFi action on Ethereum, then you should aim to not own the DeFi state so that users won't try to like buy atomic synchronous composability there, right?
Ethereum doesn't know what's happening on top of it, right? Doesn't know what.
I mean, the proposers know. They can examine.
Right. The proposers just want to maximize the value of the blocks that are being built.
Feels like there's a lot of assumptions being made here. One, that L2s want this at all, but two, that the individual sequencers, like the operators, aren't just going to kind of like coordinate out a band and be like, oh, Chris and I both have our L2s, like, and our, we're sequencing on those L2s. I could just talk to them directly, even though, like, not go through Ethereum. It's like, it's just cheaper, like, or they offer me more security or whatever. A larger bond. It seems very easy to kind of go out of band.
Yeah, if you want to go out of the band, go out of the band.
But isn't it always going to be cheaper to do that, though?
I mean,
well, if you want to register an ENS name, you can't go out of the band. You just have to do it on Ethereum.
But it seems to me like that there's a trade-off here in what kinds of guarantees we want to provide cheaply or easily to users. Like if we want to provide inclusion pre-confirmations, these don't require the system that you're talking about because they don't depend on atomic synchronous composability at all. If we want to provide execution pre-confirmations, they do.
That's correct. That's a good point, yes. Yeah. So if we don't care about synchronous composability, then we don't care about shared sequencing. Mm-hmm. We only care about these inclusion pre-confirmations, and everything becomes so much simpler.
So we're going a little bit long, but I don't think anyone minds. I know that there were some questions in the room that, unfortunately, there was no extra microphone, so no one could actually ask them. But I do want to go to the room for a few questions before we wrap up. And George, I know, wanted to ask a question to Vitalik earlier, so maybe we can start with that.
My question is towards Vitalik, but I guess the rest can answer the same one too. You mentioned in your slides previously that there is a fat proposer problem if a proposer offers this. Wouldn't this be the case for any based service, regardless whether it's pre-confirmation, sequencing, or whatever you want to, doesn't based meaning that proposer does something and per se makes it fat?
I mean, no, based rollups are fully compatible with what I call thin proposers, right? Like, imagine a world where, because of the law of God, validators are only allowed to run default geth code. In that kind of world, based rollups would be fully functional.
But we don't live in that kind of world.
Right. Okay. And so this is, and so I think it's important to when I make a distinction about what we want in terms of fat proposers, right? So the thing that I said is that I do not feel comfortable staking the future of Ethereum having acceptable UX on an assumption of fat proposers, because the Ethereum protocol process may end up going in a direction that basically ends up repudiating fat proposers, right? And the multiple proposer route is just one existence proof that there actually exist those kinds of strategies.
Another one would be the block maximization aspect of MEV burn.
Mm-hmm.
Greg?
Yeah, question for Justin, I guess, curious what Sam and Chris have to say about it, but it feels like we're getting to a point where we're just overcomplicating the base protocol by adding a lot of this in. And why not continue to go with the thesis of letting third parties actually dictate and delegate how we can build the better UX around the systems we have, and keeping the base layer protocol thin, simple, and borderline dumb. right? Like I think the more complexities we add, the more edge cases we start to come up with in this. And yeah, I mean, I think you get where I'm going with that. I mean, like, to be fair, it's like we had someone talk earlier about like schemas, right? The idea of like PBS, like builder schemas, and how we can like build blocks in a more distinctive way. Like, isn't that sufficient then compared to having like very complex, potentially even like more sidecars being added to whether it's validators or builders and so on and so forth?
Right. So I would argue that the base route is actually the most simple route, especially if you consider a base sequencing without pre-confirmations. Like, it's literally do nothing. It's like you're not even verifying the signature of a centralized sequencer. You're not verifying a finality certificate from sort of off-chain consensus.
Before Justin rebranded it, I called it total anarchy.
Yeah. Total anarchy is the simplest thing to do. You just do nothing. Now, it is true that the pre-confirmations have added complexity, but a few notes here. One is that I actually believe that this complexity might get commoditized across all consensus mechanisms, right? Like, even if you have 2-second slot times, don't you want 42 millisecond pre-confirmations? That's like more than an order of magnitude better from a latency standpoint. So I think because it is a purely bilateral off-chain agreement between the user and the sequencer, it's not something that you can really prevent unless you have, as Vitalik said, the multi-proposer or the block maximization idea.
Yeah. I mean, I think it's, one of the challenges is that, like, basically there's like complexification of the base layer that we choose to do, and then there's complexification of the base layer that gets kind of like imposed from the outside, right? And basically, yeah, if you have this, like, and complexification imposed from the outside basically happens like when you have outside actors providing these incentives, and then validators just start choosing to respond to those incentives because it's super profitable to, and then at some point, like, you start getting centralization risks anyway, right? And so I think, like, that's one of the challenges with like a do nothing route if like you think about like the EIP process doing nothing, right? Which is basically that, like had, like something like MEV Boost, like not existed, had we gone full do nothing in 2021, then like that would have, like there is a very good argument that would have just like entrenched stake pools even more, right? So that's kind of like, the minarchy versus anarchy trade-off, right? It's like, are you doing nothing, or are you doing like the minimum that you have to do to ensure you don't have to do anything more? I mean, yeah, I do think that like it's a valid possible future for like L1 to continue to be a minarchy, and like I would say if that's the path we go, then we can just honestly take that path and then basically do, let's say, single slot finality with 32-second slot times, and then we get like a nice relaxed base layer, optimize it for just like essentially censorship resistance and 51% attack recovery, and then let L2 complexity do the rest, and like that's a valid choice for the ecosystem to be made, and I do think that's like one of the choices that we should be deciding in between, but like it does have downsides too.
Mm-hmm. I mean, to me, the question of complexity, also not to pick on Stephane, but to pick on Stephane a little bit.
Whoa! The tables have turned.
Is, complexity to whom are we talking about? Complexity to us building the protocol, or complexity to users using it? And the more that we push the complexity out, the more that we push it to layer 2s and layer 3s and all of these more or less intermediary agents and intermediary protocol designers that sit in between users and the base protocols, the more complexity the user is faced with. And they're faced with complexity that, one team hasn't even necessarily tried to understand, right? Like, is a user going to do that analysis themselves? No. So I think there's both the question of the complexity of individual, quote unquote layers or parts of the system, but also the question of how complex is the whole thing that a user has to interact with, and what do they have to understand in order to interact with it safely. And to me, the latter one is the one that we really have to care about.
Yeah, I mean, a lot of what I'm hearing here is there's just multiple users that you're building against, and whenever asked, you're just incapable of kind of pinning it down. Well, like, Uniswap is important to us. It's like, that is a user that we care about. But the L2s, like, that's the future of Ethereum. And if you can't actually identify like where complexity is being pushed and where it's being kind of like receded away, it's very difficult to create like clean abstractions.
I know this complexity is getting like a little bit too much for me to handle, so I don't wish it on the users either. Any other questions? Here we are.
I had a simple question. If you could decide and change the protocol, would you have a tendency to make the block times slower, faster, or keep it the same for all the panelists?
Slower.
I think 1 day is a pretty good block time. Pushes out all the DeFi. You can still send your... Yeah.
Same. 1 day.
Yeah, it's interesting you mentioned that, because I think for finality times, there's basically, my current view is that there's exactly 2 finality times that make sense. And one of them is somewhere between, basically whatever less than 32 seconds that you can handle. And the other one is somewhere around 12 to 24 hours. And the reason why I say this is basically you have this like one binary choice, which is with your concept of finality, are you trying to also take into account the possibility of a consensus bug, right? Mm-hmm. Because like if you have 32-second finality, then like, well, what if you're the clients that did the finalizing all have a bug? Like, guess what? You still have to revert the finality, right? If in the 12 to 24-hour case, like that actually is a long enough period of time that like if some kind of serious bug happens, you're not actually going to finalize, right? And so, like, I do actually think there is validity in choosing those two, but I do also think that like a finality period that's like in between those two is like this weird Frankenstein where it feels like you end up like paying the costs of it in terms of either the protocol overhead or like really high staking limits like the 32 ETH, and like you just end up not getting the benefits.
Ethereum is the slow game.
Huh.
I mean, I think I could argue both sides. Like, there is a possible future where, like, we could have like 64 seconds slot times, for example, and basically there's 2 problems with long slot times. One is UX for base sequencing, for example, but that maybe can be solved, at layer 2 or L1 pre-confirmations. But then there's another problem with long slot times, which is LVR and basically MEV growing superlinearly and whatnot. And so if
feature or bug?
It's a bug, yeah. And so if we can design a DEX that doesn't have this issue, then I think, and we combine that with pre-confirmations or whatever it is, then we could have very long slot times. But if you were to ask me today, I would lean towards the smaller slot times just because we don't have these magical DEXs that are more incentive compatible with the LPs and the users.
You haven't answered yet?
Arjun?
I haven't. I mean, I'm still, it sounds to me like there's just a quintessential problem here, which is that you can't really optimize for all cases, and in attempting to do that, we're sort of either alienating some subset of users or providing an extremely complex underlying experience. And so I've always personally been a fan of the like original L2 thesis, which is like push everything to L2s. L1 is used for proofs and ordering and really nothing, and like security and really nothing else. And under that paradigm, I see the value of having better standardization around how things like preconfs exist on L2s, such that there is not like just a insane complexity, but it feels like there are ways to accomplish that outcome by having, like either, this is maybe a bit controversial, extending the EIP process to L2s or creating an alternative process for L2s.
I mean, one of the things that I'm most bearish about the L2 pre-confirmations is credible neutrality, right? Like every team building L2 pre-confirmations is VC backed, has a new brand, has a new token, whatever it is. Like, it would be amazing if we had a public good L2 pre-confirmation system. Agreed.
And inherently that's the reason why like something that sits at the same level of neutrality as the EIP process. And I recognize that the EIP process itself being that process may not be the best one, but yeah.
So I think we're going to wrap it up here. Thank you so much to all of the panelists. It seems like some of us want longer blocks, some of us see the benefits and the drawbacks, and some of us are not sure. Thank you also to all the crowds. We have one more talk that's going to happen after this, and then we'll go right into the happy hour, I think. So thanks again.
Thank you.